Hello, my name is Roger Moore. I'm the ROV Operations and Technical Manager for James Fisher Marine Services here at our base in Lowestoft. I'm just going to give you a brief overview first of the project, and we've titled this Below the Horizon. So in this project, you will have to design a world-class remotely operated vehicle, or ROV for short, and these are used in many subsea activities. James Fisher Marine Services use these as deep as 2,000 meters. However, for the offshore wind and turbine industry, these are a lot shallower. However, you do then have subsea tides and visibilities and currents to worry about. These expensive tools can do various tasks. So some of these, I'll go through a couple to give you an idea. You have cable burial or depth of burial surveys. Now, obviously, when you're building a wind turbine, you've got to get the actual power from the wind turbine to the main hub, and then from the main hub back to shore. So you're going to be running cables along the seabed, and these are actually buried within the sand. Now, with the shift in sands, you've also got to then look at how deep they are and how regular this is, so that there is a regular survey as well as an installation. You then get seabed surveys and site clearance surveys. Now, when you're working on various different sites, the vessel comes along or a jackup will come along and sit up on site. So when you get there, you need to know what's on the seabed, any obstructions or any debris. And then obviously when you leave, environmentally, you want to be leaving this as clean as possible. So you'll issue those sites survey and clearance survey certificates. We also have UXO investigation and disposal surveys. Now, many of you might know along this particular East Coast, it was used during the war. We were heavily bombed, not only from the other side, but also from our own pilots. Before they landed, they were also getting rid of their explosive devices. And when you're doing these cable surveys, you've got to make sure the area is clear. And again, you'll come over and you'll do a magnetometer survey. You'll find these metal items, and you then got to identify what they are. And if they are an explosive device, you've then got to either blow them up on site, or you've got to move them to an area where you can dispose of them environmentally. We then have support for subsea construction activities. We have diver observation. Sometimes you have the divers and the ROVs working together, where the ROV will actually look at the diver, and sometimes we'll go and get some tools for them. Some things you can't physically use an ROV for. Some things from the older equipment has diver valves which are operating for large wheels, so you'll actually need a pair of hands for those to do it. But generally they're starting to phase those out. You'll have platform and monopile inspections, and these can be a general visual inspection or a close visual inspection. Now, depending on what you want to be looking at, some things you need to look at a very detailed area, so you'll need to clean them, and you'll need to do UT, which is ultrasonic wall thickness testing to see how thick the steel structure is. You'll do CP surveys, which is cathode protection, and you'll look at the actual corrosion properties, how it's corroding. You will also then do, you can now do 3D photogrammetry surveys. And what these actually do is they have two particular cameras that are set side to side like a pair of binoculars, and they take two individual pictures, and they are then put together, and you can actually make a 3D model. And these are now being used with point cloud database to allow you to take millimetric measurements of these for you to allow you to build into existing components. So you can see there's lots of things for you to look at. And it's not uncommon now to use ROVs instead of divers because it's fairly safer and obviously sometimes less expensive. You'll also need to investigate different uses for these vehicles and the tasks that they can carry out before setting your design. So what you'll need to do is research remotely operated vehicles in different fields, identify a task that your ROV is going to be carrying out and plan that task. You'll need to complete an annotated design of the ROV, individual components as well that may be going onto that vehicle. You'll also be able to make a prototype using materials around your house, for example. You should start by looking into various different environments where the ROVs are used and get an understanding of how they work in general. how does the remote operation work? It's very similar to an Xbox controller, whereas you have a physical item in your hand with a couple of joysticks, and the movement that you make sends signals down the line to the vehicle. And there's lots of different ways of controlling that, whether it be through data or through fiber optics. So you can have a little look at those as well. And also what are the common features across all ROVs. You know, the smaller ones just have cameras, then you've got sonars, then you have manipulator arms the bigger you go. How will you get that vehicle from the vessel, for instance, into the water? So you'll need to look at the launch and recovery systems, how they actually move about, and what sort of weather environments that you're going to be limited with. If you've got big weather, 4.5 meter waves, for instance, will you be able to get it in the water? So have a little look at those as well. What about the clarity of the water? If it's really bad, will you want to be using a sonar? So if you can't see anything, it'd be like pitch black, or when you go deeper, it's also pitch black, so you have lights. But if the clarity is really bad, you'll then start using one of these high resolution sonars, similar to an ARIS or a Blue View sonar. Have a look at those two names. Part of this research, there's various different sites, and what we'll do is in this thing, we'll also give you a small list of places for you to look for these components, and also who makes these ideas. And there'll also be links as well to some PDFs that I'll supply. And these will be the individual vehicles that we have at James Fisher Marine Services, but also a minimum standard of what we do when we do a general visual inspection. So you can see all the terminology, and you've got a lot of information there to back it up. So that's about it for me. I will be available for questions and stuff as well. There'll be links to me to send me information and for questions and answers if you want to. And otherwise, I'll now hand over to one of the others. Thank you.